This presentation is all about working with strings in Python, a core skill for data processing, user input, and text formatting. Strings are more than just sequences of characters. Python provides a wide variety of tools for slicing them, formatting their layout, and transforming their content. In this lesson, we'll look at how to extract substrings using index ranges, format text output using field widths and alignment, and manipulate strings using built-in methods like replace, find, split, and join. These capabilities are critical for writing clean, flexible, and professional-grade Python code that handles real-world text data. Mastering strings in Python, slicing, formatting, and methods by the programming professor. The topics in this module are organized into 3 major sections. First, we'll cover string slicing, including basics, how to use stride values, and how to handle edge cases with negative or omitted indices. Then, we'll move into advanced string formatting using f-strings, where you'll learn how to control spacing, alignment, and floating point precision. Finally, we'll explore a broad set of string methods, such as those for finding, replacing, comparing, and changing case, as well as splitting and joining strings. These tools are not only essential for building readable output, but also for cleaning, analyzing, and transforming string-based data efficiently. Python strings are sequences, meaning each character has an index starting from 0. You can access individual characters using square brackets and a single index, or you can extract slices, substrings, by specifying a start and end index separated by a colon. Importantly, the slice includes the start index, but stops just before the end index. For example, slicing a string from index 0 to 3 gives you the first 3 characters. This technique is extremely useful for grabbing prefixes, suffixes, or any part of a string you want to isolate. Slicing is safe. Even if your indices exceed the length of the string, Python won't throw an error. It just returns what's available within bounds. Slicing supports more than just forward index ranges. You can also use negative indices to count backward from the end of the string. -1 refers to the last character, -2 the second to last, and so on. This makes it easy to trim characters off the end or grab content relative to the string's end. Another important point is that Python's slicing is end-exclusive. The character at the end index is not included in the result. This might feel unintuitive at first, but it allows for easy calculations of slice lengths and simplifies logic when breaking up strings into parts. Slicing with negative values opens up flexible strategies for removing trailing punctuation, domains, or file extensions. When you create a slice from a string, Python returns a new string, not a reference to the original. This means changes to the original string won't affect any previously created slices. You can also omit the start or end index in a slice to simplify common patterns. Leaving out the start means from the beginning, and omitting the end means to the end. These shortcuts are especially useful when processing the front or back of strings without knowing their exact lengths. For example, my str of :5 grabs the first 5 characters, and my str of 5: returns everything from the 6th character onward. Using slicing in this way keeps your code cleaner and easier to read. Slicing becomes even more flexible when you use variables as indices. For example, instead of hard-coding numbers, you can slice from x to y where both x and y are variable values, allowing you to dynamically extract substrings. It's also important to understand edge cases. If the start index is greater than or equal to the end index, like my str2:1, Python returns an empty string. Similarly, if your end index is beyond the string's length, Python will simply go up to the last character without raising an error. This makes slicing forgiving and intuitive for many real-world use cases. The slide also presents useful patterns for slicing structured strings like URLs. By combining absolute and negative indices or omitting one end of the slice, you can quickly isolate key segments of a URL for processing, validation, or display. Python slicing also supports a third value, the stride or step size. By default, the stride is 1, meaning Python returns every character from start to end. But you can specify a stride to return every second character, every third character, or even reverse the string by using a negative stride. For instance, my str of : 2 skips every other character, and my str of : -1 returns the entire string in reverse. This feature is powerful for tasks like sampling characters, reversing strings, or selecting characters at regular intervals. Understanding how to use stride in slicing adds another layer of flexibility to string manipulation and lets you write very concise solutions to problems that would otherwise require loops or extra logic. When printing structured data like tables, default print statements often result in uneven or jagged output, especially when string lengths vary. That's where field width formatting comes in. It allows you to specify a minimum number of characters each value should occupy, ensuring alignment and readability across rows. For example, when printing player statistics, like name, goals, and games played, you want the columns to line up neatly, even if the data varies in length. By assigning consistent field widths to each column, you can produce output that is clean, professional-looking, and easy to scan. This is especially important when displaying data in terminal-based applications, reports, or logs. Field width formatting is implemented using f-strings with a colon and width specification. For example, name : 16 reserves 16 characters for a player's name, padding it with spaces if it's shorter. By default, strings are left-aligned, while numbers are right-aligned, which makes sense for lining up columns of text and numbers. You can override this behavior with alignment specifiers: less than for left, greater than for right, and caret for center. These go directly after the colon, before the width value. For example, value : 10 centers the value in a 10-character wide field. By using these options together, you can control how your output is laid out, improving both the look and clarity of printed results. These formatting tools are especially useful when you're displaying tables, headers, or multi-column reports in your Python programs. Text alignment within a fixed-width field allows for cleaner and more controlled output formatting. Using f-strings, you can align text to the left, right, or center within a specified number of characters. This is done using a format specifier, where you place less than, greater than, or caret before the field width to indicate the alignment direction. For example, value : less than 10 left aligns the value in a 10-character field, value : greater than 10 right aligns it, and value : 10 centers it. By default, Python left aligns strings and right aligns numbers, which makes sense in many cases, but can be overridden when needed. Proper alignment improves the readability of structured text, such as when you're printing column headers, labels, or tables. These formatting options are especially helpful when you're designing command line interfaces or any output that should look organized and uniform across different runs of your program. You can also enhance alignment by using fill characters, custom symbols that pad the empty space in a field. This is especially helpful when formatting numbers or when you want a stylized output. The fill character is placed before the alignment character in the format string. For example, score : 0 greater than 4 pads the score with zeros on the left, resulting in something like 0009 for a 4-character wide field. Other options include padding with dashes, asterisks, or any character of your choice. Fill characters are often used in progress indicators, serial number formatting, and table designs where extra spacing needs to be visually consistent. Understanding how to control both alignment and padding makes your formatted strings look polished and intentional. When working with floating point numbers, controlling the number of decimal places shown is essential for professional-looking output. Python's f-string formatting allows you to specify precision using the .precisionf syntax. For example, value :.2f rounds a float to 2 decimal places. You can combine this with field width by using width.precisionf, such as value :6.2f, to control both alignment and number formatting. This is especially useful when displaying things like monetary values, calculated ratios, or percentages. Python will automatically round the number and pad it with trailing zeros if needed to meet the specified precision. These small formatting details make a big difference in clarity when displaying statistical data, financial reports, or any output that requires consistent numeric presentation. Python strings are immutable, but they come with a robust set of built-in methods for transforming their content. One of the most useful is replace, which substitutes one substring for another. You can replace all occurrences or limit the change to a specific number using an optional count argument. For example, replacing cats with dogs changes all matching substrings unless a count is specified. It's important to remember that these methods return a new string. They do not modify the original. This immutability prevents unintended side effects, but it also means you'll need to assign the result to a variable if you want to keep it. Replace is particularly useful for cleaning up data, editing output, or creating templated strings with dynamic content. To locate substrings within a string, Python provides methods like find and rfind. The find method returns the index of the first occurrence of a substring, while rfind searches from the end of the string and returns the last match. You can also supply start and end indices to narrow the search range. If the substring isn't found, these methods return -1. These tools are essential when parsing or validating input, such as checking if a file name contains a certain extension or if a sentence includes specific words. Additionally, the in keyword allows for a quick existence check, returning true or false without needing the index. This makes it easy to write conditional logic that depends on whether a substring appears in a larger string, which is common in everything from filtering content to building search tools. You can also count how many times a specific substring appears in a string using the count method. This method is straightforward and powerful. It returns an integer representing the number of non-overlapping, case-sensitive matches of a substring. For example, counting O in the string boohoo returns 2. This is useful in many contexts, like determining word or character frequency, validating input length, or scanning logs or data for patterns. Because it's case-sensitive, abc.counta would return 0. So if you need case-insensitive matching, you'll need to normalize the string with .lower or .upper first. As with other string methods, count doesn't modify the original string, but returns a new result for you to use as needed. Python supports rich string comparison using standard relational and equality operators. You can use == to check if two strings are exactly equal, and less than, greater than, less than or equal to, or greater than or equal to for comparison of their lexicographical order. These comparisons are based on ASCII or Unicode values, so capital letters are considered less than lowercase ones. For instance, Yankee is greater than Amy because the ASCII value of Y is greater than that of A. It's also important to note that comparisons are case-sensitive and stop at the first character, where the strings differ. The in keyword can be used to check whether a smaller string is contained within a larger one, returning a Boolean result. Be cautious not to confuse equals equals with is, which checks for object identity, not value equality. For string comparison, always use equals equals. Since string comparisons rely on ASCII or Unicode values, the case of letters matters. Capital letters have lower ASCII values than lowercase letters, so apple with a capital A is considered less than apple with a lowercase a. This means that sorting or comparing strings can yield surprising results if you're not accounting for case. For example, banana less than apple evaluates to true. To avoid logic bugs, make sure you're comparing normalized strings, either by converting both to lowercase or uppercase. And remember, the is keyword should not be used for comparing string values. It only checks whether two variables point to the exact same object in memory. For actual string content comparison, always stick with equals equals. You can refer to an ASCII table to better understand how characters are ordered and how comparisons are evaluated internally. Python includes several Boolean string methods that return true or false, depending on the content of the string. For instance, isALnum checks if the string contains only letters and digits, while isDigit confirms that it contains only numeric characters. Other useful methods include is, lower, is, upper, and is space, each testing for specific character types or patterns. The starts with and ends with methods are especially helpful for validating input formats or checking prefixes and suffixes in structured strings, such as file names or URLs. These Boolean methods are often used for input validation, filtering, and conditional checks in larger programs. They help you ensure that user-provided strings meet specific criteria before processing them further. In addition to Boolean checks, Python provides transformation methods for converting and cleaning up strings. These include capitalize, which uppercases the first letter and lowercases the rest. Lower and upper for changing all characters to lowercase or uppercase, respectively. And title, which capitalizes the first letter of each word. The strip method removes leading and trailing whitespace, which is especially useful when handling user input. For example, input.strip.lower is a common pattern to normalize text before comparison. These transformations are essential for preparing data for analysis or display. They ensure that string comparisons are reliable and output formatting is clean. Using these methods early in your workflow helps reduce logic errors and creates more robust and user-friendly programs. The split method is one of the most commonly used tools for breaking apart strings into lists of substrings, or tokens. By default, split uses whitespace as the separator, but you can pass in any string to use as a custom delimiter. For example, splitting a string on the pound character breaks it into components wherever that character appears. The separator itself is not included in the result. The method is especially powerful when dealing with structured data, like full names, comma-separated values, or logs, where consistent delimiters are used to organize content. The resulting list of substrings can be indexed, looped over, or further processed. Whether you're parsing input, analyzing text, or transforming data, split is a foundational method for breaking strings into manageable pieces. When working with structured inputs like URLs, the split method becomes especially powerful. In this example, the program prompts the user to enter a URL, and then uses split with a / argument to break it into components at each slash. The result is a list of strings, or tokens, where each token represents a segment of the URL. If the URL has consecutive slashes or ends with a slash, the resulting list may include empty strings in those positions. This behavior is useful to understand when processing file paths, routing patterns, or domain structures. Once a URL is tokenized, individual segments can be validated, transformed, or reassembled as needed. This method of breaking down input is foundational for building parsers, handling web data, and managing dynamic routing in web development. The join method is essentially the reverse of split. It takes a list of strings and combines them into one string using a specified separator. For example, if you pass the @ symbol as the separator and the programming professor, and Gmail as the list, it returns the programming professor at Gmail. This method is clean, efficient, and much more readable than using a loop with string concatenation. It's especially handy for constructing email addresses, file paths, or structured strings like URLs or CSV lines. Whether you're formatting output or generating content dynamically, join gives you full control over how the final string looks, all while keeping your code compact and easy to read. Instead of building strings manually using loops, Python offers a much more concise approach with join. The traditional approach involves initializing an empty string and appending each list element inside a loop. While that works, it's less efficient and harder to read. The join method, on the other hand, combines all list elements in one clean operation, using a specified separator. This is the recommended way to build strings from lists in Python, especially when working with long lists or generating structured content like messages, CSV rows, or HTML. It produces the same output with fewer lines and less chance of error, making it the go-to method for string construction in most professional Python codebases. Sometimes, you'll need to split a string and then reassemble it using a different separator. This approach is particularly useful when normalizing file paths or converting between platform-specific formats. In this example, the user inputs a file path, which is first split using / as the separator. Then, the program prompts for a new separator, which is used to rejoin the tokens into a new string. This technique is clean, reusable, and much easier than trying to manipulate strings with index slicing or loops. It's especially useful when you need to swap out delimiters in paths, URLs, or identifiers, and it's widely used in tools that must work across Windows, Mac OS, and Linux environments. There are situations where you not only want to split and join a string, but also edit the tokens themselves before putting everything back together. In the example shown, a user-entered Wikipedia URL is split into parts, and the code checks whether the wiki segment is present at the expected location. If it isn't, wiki is inserted into the list at the correct position. After the update, the list is reassembled using join to produce a corrected URL. This kind of logic is excellent for validating and sanitizing input, ensuring that URLs, paths, or identifiers conform to a standard structure. It also illustrates how string manipulation, list operations, and conditional logic can work together to build user-friendly and fault-tolerant applications. To wrap up, we will revisit the major concepts you've learned about string manipulation in Python. Strings are sequences, meaning you can access and slice them using index ranges and even apply strides for custom stepping or reversal. You've seen how to format strings for output using field widths, alignment, fill characters, and floating point precision, all essential for creating readable, well-structured program output. Python also includes a robust set of string methods for searching, replacing, comparing, transforming case, and validating content. Finally, we explored the split and join methods, fundamental tools for processing structured text like URLs, file paths, and user input. Mastering these operations will significantly improve your ability to clean, transform, and present string data in any Python program. Whether you're writing a data parser, a command line tool, or a web scraper, the techniques you've learned in this module are crucial for building clean, efficient, and reliable Python applications. Thanks for watching. Let me know in the comments if there are other topics you would like me to talk about. If you enjoyed this video, please like, share, and subscribe for more content on software engineering and technology. See you next time.